So let's start with the definition of, start with the question, what is a string? A string is a collection of characters, and a string is not a primitive data type. And that basically means it's not part of the programming language. It's a type of data that has been created after the establishment of and the production of the programming language itself. Um, computer computer engineers and compiler designers and programmers realize that strings is a really important part of programming because it's a form or a method we use to store information or process information, and also it's a way that we can let the program communicate with users. So after they created the programming language itself, they decided to create the string. And again, most of the time, you'll be using strings to store your name, your ID, your address, course titles, and most of the things we think about that's not numeric, we usually think about them in the form of string. So to create a string, we basically need to start with the keyword string, and then you call whatever you want. For example, name. Let me go with a full name, for example. Full name. Now, this is me creating a string. Of course, I can create a string and initialize it if I want by typing equal and then double quotations, and you just go ahead and give it a name. Or you can go ahead and do it in a separated line. That's acceptable, but it's usually recommended to do it in the same line. So here we go. This is a string. This is how we create a string. Now, if you want to show a string on the screen, see out, and you just type, for example, full name. And line semicolon. Now, of course, you can see here that he's complaining here. And the reason why he's complaining, because as I said, this is not a primitive data type. So the compiler will say, well, you know what? I have no idea how do I show a string on the screen, because cout is not designed to show a non-primitive data types. And because of that, this is something that you guys are going to learn later in a future class, not even in this one, something called operator overloading. And this operator overloading that we don't know what it is, it's basically something that you need to include in your project so you can solve this problem. And for that reason, we need to include a string header file. And now that should fix it. Now, this is the opposite of, for example, integer num, for example, equal 100. You'll see here, if I type cout num and line, the compiler would not complain about anything. Why? Because num is a primitive data type. And this is the insertion operation that I'm highlighting right now, actually is designed to handle primitive data types, but it's not designed to handle non-primitive types like string here. So for that reason, we had to include this header file strings to solve that problem. In the future, as I said, you will learn how to reprogram this operation. Now, let's keep going. So this is how you actually show a screen on screen. This is how you create a string. Strings comes with a list of methods related to strings. For example, I can come here, let's just put a space. And then I can come here and say full name dot length. This will tell me how many characters do I have in this string here. If I want to have access to a character in a string, I can say full name dot at, and I can put, for example, 1 and line. This will show me which character I have at location or position 1. Now, something you have to understand here, we have 5 characters here, but when we count the locations of these characters, we start counting from 0. So this A here is at location 0, this H has location 1, M is 2, E is 3, and D is 4. So even though I have 5 characters, but when it comes to the counting of the locations of these characters, it has to be start counting from 0. And again, we have a real long list of functions. I'm going to try to show them as we go. So here it is. This is string. Now, one of the biggest problems we have with strings is the cin. How do we perform this operation? For example, if I come here and say cout, enter the name of, enter your full name. So I'm going to come here and try to do that. If I come here and say cin, I'm going to type, for example, full name, put semicolon here. Let me try to run this, and it'll show you that this will be a problem. Of course, I have to switch sharing. So here it is. This is the first line. Now he's asking me for my full name, for example. If I go ahead and type that, if I press enter, well, I didn't try to show it on the screen. Let me try to do that again. One sec. Let me follow that with a cout, and I'll just say full. Sorry, let's just put it here. Full name, no space. Line semicolon. So I'm going to run it again just to show you. Before I do that, let me fix this extra space. Let me run it. Let me share my screen. And here we go. And look at that. Now, as you can see here, I entered the full name, but the compiler only took the first name. Now, here's the thing. When you use cin takes space and enter as a separator between two enters. So what's going to happen, the compiler will take Ahmed here and assign it to the full name, and then see there's a space, so it's going to stop the process of assigning Ahmed to the variable, and it's going to read Al-Janabi. Now, since there's no other variables that I'm trying to read, it's going to put it inside a buffer. It's basically a temporary space inside your memory, waiting for you to ask for a new variable, so Al-Janabi will be assigned to it. So you can see here, this is causing problems. First of all, I'm not seeing my full name here. And second of all, if I have another input operation after this, it's not going to work. It's basically going to immediately assign Al-Janabi to whatever you're trying to read after that. So the bottom line here is you cannot use cin reading from a string, for a string variable. So what do we do in this case? Well, we do have a tool. It's called Getline. Getline takes two arguments, and I think the first one is cin, and the second one is full name. Now this should fix the problem. Now let me go ahead and run it. Let me share the screen again, and I'm going to go ahead and do this. Here we go. It worked with no problems. Okay. Now the last part I'm going to talk about here before I go and check, what do they call it? Check the ZY book. I'm going to come here and try to do some operation. I'm going to come here and say, let's say integer num. Now say cout, enter a value. Here and put this here. Put semicolon here, and then cin, and I'll put num here. Now, it's always like you have to be careful whenever you mix and match between cin and Getline. Of course, because I'm reading a variable here, I need to go with cin. But let me show you what's going to happen here. We have two cases, I believe. One of them, if you use cin before Getline and cin after Getline. So let's start with the first case. If I have a cin before Getline. So I'm going to type, let's say 12. And look at this. Immediately, he didn't even give me a chance to enter the full name. And there's a reason for that. The reason is after I typed 12, I pressed enter. That enter was fed to that buffer. And then after that, I got Getline. Getline, before I start reading from the keyboard, went back straight to the buffer to read what's in the buffer. And it found there's an enter in that buffer. And that enter was assigned to the full name. And that's why you see nothing printed on the screen. So this is something you have to be careful with. Now, let me just take this and I'm going to copy it. And let me just comment this section here. I'm going to go ahead and put it under here. We should not have any problem with that case. I'm going to show you the solution, of course, for this case, once I'm done showing you that having a Getline or a CN after Getline should not be a problem. Enter a full name. Okay. So I'll go DDD, TTT, and now enter a value, 12. And it worked. So how do we fix this problem now? Let me just take this away. Well, if you have a case like that, you need to flush the buffer. And to flush a buffer, you just have to type cn ignore. I'm trying to make sure that is it cn or ignore cn. You put a number here, semicolon. I think it's ignore cn. He doesn't like either one of them. cn.ignore, sorry, cn.ignore. Yeah. Now, since I entered one value with one enter, that should flush it. And you just have to count how many times you pressed enter, and you put a number here that will match that number. Of course, if you put more numbers, you're going to have a problem. But let's just go ahead and see if this is going to fix it or not. So I'm going to go 12, and now I can enter my full name. No problems. Oh, you guys didn't see that. Let me run it again. So here you go, 12, and then DDD, TTT. Here we go. So you just have to be careful whenever it comes to mixing and matching those elements. So let me just go to this UI book to make sure that I didn't forget anything. This is just to show you how strings are constructed, some true and false questions, strings variable and assignment. Those are just examples. Getting strings without white spaces from an input. I just explained that problem. Here is another example. Some questions, another example. You guys can go ahead and read them whenever you guys have a chance. Mixing a CN and Getline, you're gonna have to be careful with that. And that will be it. Now, let's move on to the second topic of the class of today, the integer overflow. What is an integer overflow? Integer overflow basically means when you don't have enough space to store a value. Now, every single variable you're going to create, as we said before, you need to define the data type for that variable. And when you go ahead and use an integer, for example, there is a minimum value you can store in an integer and a maximum value you can store in an integer. Anything between those two values could be stored in an integer. But the moment you pass that value greater than, or the moment you pass that value less than, this is what you get, an integer overflow, and that will cause an error and your program is going to crash. What we need to do, let's look here. For example, the decimal number, blah, 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 requires 32 bits binary. 32, well, 33 actually. So this is going to be overflow. If you try to assign this value to an integer, you're going to have an overflow because we know an integer requires 32 bits and this one requires 33 bits. So that's going to be a problem. So he's just going to here telling you that you need to be careful whenever it comes to creating integers, because if you get an overflow, the program is going to crash. Well, how do we solve that problem? Well, integer has many versions. Let's put it that way. And those versions, we're going to talk about them now. So you should know the range of values that you have, and based on that range, you will be able to decide which variant of integer you should use. Now, the first one we're going to talk about here is called long variable. Long variable is basically an integer that is way more bigger than the traditional integer and can have more values than it. So let's see here. In this example, let me just zoom a little bit. What do I have here? I have 1,000, and then I'm going to multiply the 1,000 by 1,000. Remember here, this is an integer. Let me run it just to show you what's going to happen here. I think here it is. This is the part. So the first num was okay. The second num was okay. The third num wasn't okay. And look at the value that we got. We're not supposed to get this value. We're supposed to get this value plus 3 more zeros. So that's not going to work. As you can see here, why is this happening here? This random? Because we are running out of the range of the integer. So the problem, to solve this problem, let me see here if I can just come here and change this. Long, and let's try to run it. And here it is. So long again, should be explained here about the size of it. I think it's supposed to be double the size of an integer. Okay, I think it's going to be explained here, numerical data types. So here we go. What do we have here? We do have a character. Now let's look at those data types. A character, the size of a character, we talked about character. We said we can store only a single character in a character, and we basically treat a character in, as a decimal if we want to. And I believe I showed you guys some examples about that. But you can see here the range of a character could be between -128 and +127. Okay, now a short is half the size of an integer itself. So this is an integer and this is a short integer. And you can see here is 16 bits, here's 32 bits. This is the range of the values in short. So it can go from -32,000, blah, 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 to +32,000. Now here is the big spaces. Here we go. We got the long integer, 32 bits. And this is a long, which is 64 bits. As you can see, it's way too long than the traditional integer. You can see here the range of values you can use with the long and with the integer are very, very similar. The minimum size, there one is 32 and this one is 16 bits, which basically is not a big deal. This is what's important here, the range that you can store a value. So it looks like the integer and a long are very, very similar. And that's why we had to go with the long. So we can have more space. And look at the number you can store in a long. Look how big is that number. Of course, because you have 64 bits, so that's a wide range of bits. So you can store big values or small values inside that variable. Now, in addition to those different types of integers or variants of integers, we have something called unsigned. Well, he didn't talk about unsigned here, so let me just go with the float here. We also talked about floating points in numerical values. We have float, we have double. You can see here the difference between them. The float is 32 bits and the double 64 bits. And by 32 and 64, I'm talking about the reserved space inside the memory. So how much memory you gonna reserve to store an integer, a float, and how much memory you would reserve to store a double. And of course, the higher this value is, the wider the range of values you can store. So look at this, 32 bits, you can store a number that goes from -3.4 multiplied by 10 to the power of 38 to the +38. Now look at the double, -1.7 multiplied to 10 to the power of 308 to +308. You can see the wide range of values here. And again, usually those values, we use them with scientific. We need this precision with scientific calculations, but we usually use it also whenever we have a variable that accepts the decimal point. So we talked about the real number data types that doesn't accept the decimal point. And now we talked about the float with a decimal point. And what else do we have here? Rooms of 32-bit floating values. You guys are going to have a class called discrete structure in the future. This is going to be explained in a lot of details, because how are you going to put a number like this in a computer systems? Well, this is how it was going to look like, but that's not a big deal here. Okay, now we're going to be moving on to another concept in programming, which what we call unsigned. Now, Um, let's go back to the integers, for example. If I ask you how many kids you have or how many phones do you have, you're going to tell me 1, 2, 3. That's acceptable because it's countable. But sometimes some measurements doesn't accept a negative value. And if you're going to go, let me just go back to the table that I showed you before. Look at this here. For example, this character, it goes from negative 128 to positive 127. Now, the question that I'm asking here, what if having a negative value is not a possibility for me? Like I'm trying to measure something and that something could never be a negative value. Well, if that's the case, and you know that's the case, we have a special keyword that we can use. It's called unsigned. Now, when you put the word unsigned in the front of the declaration of the data type, look what just happened here. It goes from 0 to 255. Now, compare this to the traditional character, which start from negative 128 to positive 127. Now, since there's no negative values, the range that I have, it's still the same amount of values, but starting from 0 all the way to 255. Same thing here with the unsigned short. Previously, it was negative 32,000 something to positive 32,000 something. Now look here, 0 to that number. And same thing here, and same thing here, and same thing here. So choosing unsigned, again, that's something smart to do, especially if you know that negative values are not acceptable. So always think about that whenever you create a numerical variable. So unsigned, long, you can see here, those are just examples. But again, remember here, the moment you choose a variable to be unsigned, that basically means you cannot have a negative value stored inside it. So you have to make sure your calculation will never lead to a negative value to be stored in any of those variables. Random numbers. Now, if I'm going really fast, I want you guys to stop me at any time. If you have any questions, please let me know. Let me make sure that I can see the chat box. So in case somebody asks a question, I can answer there. Okay, now the following part is one of the fundamentals operations that we need to know how to do whenever you work in any programming language, not necessarily just C++, any programming language. You need to know how to create a random number. Now, why is this important? Let me just tell you one example. Video games, for example, it's built based on random numbers. If the same thing will happen over and over and over again, it's not fun anymore. So you need to add some level of randomness. Gaming is the best example here. But again, that's not only the applications. There's a lot of other applications, especially simulation softwares. Random is a kind of big deal. Statistics, random is a big deal. Probability, random is a big deal. So there's a lot of applications that rely on creating random numbers in your program. Now, the question is, how do I make my program create a random number? Well, the idea here is very simple, and I'm going to just jump to, where is it? I'm going to share my screen. I'm going to move here, and let me just put a divider here. And I'm going to comment this section. I'm going to try to upload this file later. Okay, so to create a random number, number one, you need to include some header files. But the idea here is to use a function called rand, R-A-N-D. So let me just go ahead and show you what is that rand function. I'm going to come here and say integer. Let's call it num1 equal rand. I'll put semicolon here. And what I'm going to do, I'm going to show 3 values because I want to ask you a question. Is this real random number, or there's something not quite right about it? Let me try to run it. And, oh, sorry, I was supposed to show them on the screen. I forgot about that. See out. Num1 put a space, and then num2, let's put a space, and num3, let's go end line, semicolon. Now let me run it, and let me show you the numbers. So here's the numbers that I got: 41, 181. I don't. You guys try to just focus on this one. Is very easy to remember: 41, 6334, 18. Let me run it again. I'm going to run it, then I'm going to share the screen. I'm not changing anything. So let me share the screen again. Where is it? And come on, where is it? Oh, here it is. So look at this. Same numbers, exactly. Let me run it again. And look at the numbers. Let me share the screen again. You can notice here that every time I run this program, it's generating those three numbers. I can see that, but they're not changing. Just like every time you run the program, you get the exact same values, which are kind of randomly selected, but they're not exactly random, because if they're random, I'm supposed to get three different values every time I run the program. So obviously there's something not right about using this random function. The idea here is that you should understand random function use what we call a seed. And traditionally, if you don't specify a seed, I think it's just going to go and use 0 as a seed. And because it's going to be using a number as a seed, the same value is going to be repeated over and over and over. So what do you need to do? You need to include some factor in this equation that change with time. And what does change with time more than time? And that's why we need to include time here in our calculation to get the right, to get a random value. So to do this, srand, you open a parenthesis, you come here and type time 0, and put semicolon here. Since I'm using time, let me try to make sure that I get this right. I think there's a header file that I need to include. But before I do that, let me make sure that I got this right. Yep, it's time, so that's right. I need to go here and include the header file. It's called ctime. Okay, so what's going to happen here? Every time you run the program, and instead of having those seed points where they're fixed the same values for each one of those, that really produce the same random value every time you run the program, those values are going to be replaced with another factor, and that factor is going to count the time in milliseconds at the moment I run this program. So every time I run the program, I will guarantee that I will get different values. So let me just run it again. And let me show you the screen now. And you can see here that the values are changed. Let's focus on this, 6551. I'm going to run the program again. And you can see here, they're different. Sorry, I didn't share the screen. But you can see here now, they're different. Every time you run the program, a different integer value is going to be produced. And that's how we do and create random values. So it's important to understand that there's a function called rand, but you need to understand that this rand function will always give you the same value if you run it. And for that reason, we need to include time as a factor in the calculation. So here, before the process of calling this rand function, you need to call this function called srandom, and you include time 0 as a factor. Now, time 0 is defined inside this header file called ctime. This time 0 will return the moment when you run the program in terms of, I think, seconds or milliseconds. I think it's seconds. You can try that if you want. Just see out time 0. It's going to tell you what is the value, of course. We probably will have a whole chapter to talk about that later. But the point here is, this is how it's going to generate 3 different values. Now, the question that we need to know now, those values that I'm going to generate, what are they? Well, let's start with this. They're positive values. Oh, sorry. We start from 0 all the way to a positive number, and that number is basically as big as the integer can handle, and it's going to be positive. So the question is, what if I want to control the value that's going to be assigned to num1? I want to control that random value. For example, let's imagine this is a dice. And let's imagine this one should go from 0 to 100, or let's say 1 to 100. This is 1 to 6. And let's say this is 1 to 50, for example. That's the range that I'm looking for, or 0 to 50. Okay. Now, here's how it's going to work. If you come here and you module this random with the value of 6. You remember here, modulating basically means you divide and return the remainder of the division. So when you module with 6, you probably will get a value between 0 to 5. That's what you're going to get here, 0 to 5. So if I want to get 1 to 6, all I have to do is to increase 1 here, and you'll get 1 value to 6. Same thing here. If I want to get a value between 1 and 100, you modulate with 100, and that basically will give you a value between 0 and 99. You increase it by 1, and you will get 1 to 100. Now, if I want to get a value from 0 to 50, remember 0 to 50, I have to module with 51. Okay, that will include 0 and will go all the way from 0 all the way to 50 because I moduled with 51. We'll never pass 50. So here we go. Those are my 3 integers. And if I run this program, let's run it, and you'll see the values that's going to pop. Let's share the screen. And you can see here, I got 3, 21, and 21. This is just a coincidence that happened that I got 2 values the same thing. Let me run it again. And let me show you the screen. And here it is. You can see now they're different. And that's how you generate random values. So let's go back to ZY book. Here we got some examples about how does it work, what is the seed, and here it is, time 0. Look at this, return a number of seconds since January 1st, 1970. So you can go ahead and just give this a try. You'll see that the value is going to give you a really big one. Okay, here's more examples about that. And I think he just wants you to create a function that will generate 2 random values between 0 and 9 in this area. Okay. Now, let's move on to the it's not a second topic, the next topic, which is debugging. Now, this part doesn't do that much with programming in general, but let me just give you some sort of definitions here. An error in a program is called a bug. And fixing errors in programming, we call it debugging. And debugging by itself is the process of finding errors and fixing them in programming in general. Now, we need to understand that we have 3 main types of errors, or 3 types of errors. We have what we call syntax errors, we have what we call logic errors, and we have runtime errors. Those are the 3 types of errors that you will be handling most of the time. Fixing those errors is basically what we mean by debugging. It can think about it as troubleshooting in another word. So syntax errors is the easiest error that you will be dealing with. Why is it the easiest error? Because the compiler would take responsibility of telling you, what did you do wrong? And sometimes it's going to actually suggest some solutions for that error. But again, with time and experience, you'll get to a point, the moment you see the error, you don't even need to read the error. Just, oh, there's something wrong here. You look at it, you'll be able to tell what's wrong with it. So let me start with the syntax error. I'm going to go and jump into Eclipse, and I'm going to make a mistake here, integer with an uppercase T. Now, immediately the compiler will give you a wavy line here. It's going to tell you, well, I have no idea what is this. But imagine you're not looking at it. So if you run it, oh, there's an error. Do you want to run it? No, don't run it. Look at the message here. It's going to tell you, well, you have a problem at line number 22. Double click on it. It's going to take you to double 22. Oh, here it is. I can tell the error is here. This is syntax errors. It's easy fix. And now I'm done. If I build it again, it will be built with no problems. So you can see here that syntax errors are easy fix. Okay, let me show you one of them. For example, if I take this one away, like I did before, well, it should give me an error now, and it's doing it. Don't run it, and here it is. It's telling me I have no idea what is time. Now again, so imagine you're dealing with time for the first time. Of course, you would know, I don't know what's a problem, but again, with experience, you should know that, well, time is undefined. He doesn't know what is time. So there's two possibilities. It's you misspelled something here, or you don't have the header file that you need. This basically will be built from experience and also research. Like every time you see an error like that, just go ahead and search for it. And I'm pretty sure millions of people have the issue, and some people will tell you what is wrong with the project that you have there. So this is again what we mean by syntax errors. Now, syntax errors are easy fix, as you can see here. The problem we have is logic errors and runtime errors. And let me just explain the difference between them, and then I'm going to show you how do we fix them. Logic runtime errors is basically error that's going to happen while the program is executing, and the program is going to crash because of that error. Okay, and there's a lot of reasons why that may happen. Like if the program is working, everything's okay, and then boom, it's not working. The program is crashed while executed. So you were able to compile it and build it, no problems. But when the user started using it, something went wrong and the program crashed. Usually, runtime errors are associated with some input for some data. For example, you have a space reserved for your data, and then in the process the program is executed, that space is not enough for the data anymore. Boom, the program is going to crash. You have a variable called num. It's an integer. You ask the user to enter integer. He entered DA instead of 32 or something. Boom, the user made a mistake. The program is going to crash. So runtime errors, usually, they're not fixable. Like you cannot have them fixed, but what you can do, you can have something called exception handling, which we're going to have a whole chapter to talk about that. And exception handling basically means you put a scenario for every single possible way that the program could be crushed, and you support and provide a solution for that problem. So before the program is going to crush, the program will be able to find out why is it crushing and get it fixed automatically without the program crushing. So there will be, as I said, a whole chapter to talk about runtime errors. But the one that we're concerned about here is what we call logic errors. Now, logic errors, there are two reasons for a logic error. Reason number one is a mistake that you did in your code without realizing it, that led for the program to compile with no problem, but it's going to give you unexpected results. So what do I mean by that? Just imagine, instead of adding here, I decided to multiply. And instead of multiplying by 1, I'm multiplying by 3. See, the program, there's nothing wrong with here dividing by, multiplying by 6 and multiplying by 3. But again, imagine this is a dice, okay? We're talking about dices here. Let's do the same thing here. And let's do the same thing here. So this is supposed to be a dice game, okay? Now, if I run it, and let me show you my screen. Look at this. I got 0, which doesn't make any sense. I got 3, which is acceptable. And I got 9, which is not acceptable. So you can see here, the results are not correct. This is what we mean when we mean by a logical error. Like the results you're getting are not what they should be. For example, you have a program that's supposed to calculate the distance from your home to your college, and you're getting a negative value. That doesn't make any sense. But the program is working. It's not crushing. It's not giving you any errors. That's a logic error. Now, as I said, logic error could, there's two reasons for a logic error. Reason number one, a mistake like the one that you're seeing right now. I mistakenly typed um, the module operator is supposed to be added to 1, but I'm multiplying it by 3. Now imagine I have no idea that this is the reason for the error. Okay, I'm just looking at the whole project. Okay, why am I getting unrealistic values in this area here? Of course, I'm going to show you how to fix that. But before we go to that, there's another possibility for getting a logical error. And that possibility is the biggest nightmare of anyone who's doing research. The whole idea is wrong. Like imagine you're working on a project for 5 years, and then at the end, you just realize that after you create the project, you're running it, the results you're getting are not correct. You went and you looked at the project, at the files, at the code, you made sure that everything is correct, and then all of a sudden you realize the whole methodology that you're using in that project is incorrect. This is where you have to throw everything away and start from zero, or you have to go and do a deep research about the problem in your idea and your method and try to update it to be correct. Now, whatever is the scenario that you're dealing with, whatever the case that you have, you should know that there is a way that you can actually monitor the execution of your project. And this way, it's called debugging again, as I said before. And the idea is very simple. And I want you to use this in your daily life, like whenever you have a problem in C++. What you need to do in Visual Studio is to just mark the area that you think something can go wrong. And in my case, we're talking about this area here. So I'm going to come here at the first line at this point here, click here. You got this red dot. I'm going to go and put a red dot here. And look what I'm going to do. I'm going to run it. And look what's going to happen after I run it. I hope you, let me see if you guys seeing the same window. Yep, same window. Now let's look here. Look at this. At the bottom here, look at this. I do have num1, num2, and num3. Those are my 3 values. This is the value that's assigned to those values at the beginning. So what do we do here? We're going to go step over, and it's going to take me to, and look at this, time. Time is returning this value. Now, if you go back from January 1st, 1970, and you calculate how many seconds are there till this moment, you'll get that number. Now, okay, so this is time. Now, let me just run and go to step number 2, and here it is, 12. Immediately, I realized num1 is 12. I know num1 should never be 12. So I am going to flag this area here as, oh, there's something wrong here. And then I go to the next one. I got 0. Oh, that's not acceptable as well. So there's a problem here. Go to the next line. There's a 3. This is okay, but we cannot tell if it's okay or not completely. Now that I know that I have a problem in those 3 lines, and then I go and just check and say, oh, look at this. This is supposed to be +1. This is supposed to be +1. And this is supposed to be +1. Okay, so once you realize the problem and you fix them, you can stop, and then you can take those out, and then you can run the program and you will get the right answers, as you can see here. So that's, again, your way and your best friend in programming to fix your problem is basically to highlight the area where you think there's a problem, and then you monitor the variable window that you had at the bottom here, and just look at the values and how they change every time you move from one line to the other, to the other, to the other. And by monitoring those values, you should know the right value in your head. You compare them with whatever the program is producing, and that's where you can tell if your program is doing a good job or not. And that's basically what we mean by debugging. So you'll see a lot of examples here about debugging, where's the problems, and how do you fix them. It's a good idea to go ahead and have a look at those examples to see how do you fix them. Okay, now this here is a new in C++, auto variable, a data type. An auto data type is your best friend in a lot of cases. And I'm going to show you what it is. Sometimes it happens in programming. You're dealing with a variable and you're dealing with a data, but you're not 100% sure what type of data is that. So we have a data type called auto. The auto basically means let the compiler check the value that you have and decide what data type it should be. For example, this example here, when I said auto I equal 5, the compiler would choose the best option to store 5 in. And because here there's a decimal point, the compiler will say, well, since there's a decimal point, I cannot use an integer. So it's going to go ahead and choose the right value for this. So let's go ahead and look at this. Auto, this is going to be an integer. This is going to be an integer. This is going to be a double. This is going to be an integer. Auto X. This is going to be an error. Why is it going to be an error? Because there's no value for the compiler to estimate what kind of variables that should have. This is supposed to be a character because of the single quotations that you see here. This is supposed to be a string. Now the question is, does auto support strings? Nope, it doesn't. Auto only works with primitive data types. So since string here is not a data type, so it's not going to work. And here we go. So this is just to show you how does it work. I personally use it a lot. And you can overload this auto thing, but again, we're not talking about overloading right now. But in the future, when you get to a point where you're going to deal with STL, standard template libraries, data structures, iterators, you will see that auto will be your best friend there. Now, I think this is the last part until we jump into two examples that we have there. How do you write a code? Now, one of the things you need to understand about programming is you're not writing a program for yourself. Okay, that's not what you're writing a code for. 99.99% of the time, you're writing a code for someone else. So you're writing a code for your teacher, you're writing a code for your colleague, you're writing a code for your company that you work for. So it's very, very important that when you write a code, people who are going to come after you will be able to understand what you're writing. So there are a few points that you have to pay attention to whenever you write a code. Number one, white spaces. Look at this. This here is acceptable by the compiler. You can totally write a code like this and this, even though we didn't talk about if a statement yet, but this is acceptable. But whoever's going to read your project will not appreciate you doing this. He wants you to have a statement in a line. That makes it a lot easier for people to understand. Don't include extra spaces. The extra spaces basically get people confused as well. What's going on here? Yeah, add some extra spaces between operations and variables. So you can see here that this is, again, the compiler will not complain about this, but if you do it this way, I don't know why he's complaining about this. It looks exactly the same as this one. Oh, because of this extra space here. Okay, now we're going to talk about if statements later, but this is acceptable. You should have a single tap in this area here between the X. This way, I would know that this is a block of code. When we get to the if statement, we're going to explain that. But look at it, the space here is way too much. Or here, there's no space at all. Brackets. Again, when we're going to get to those repeat structures and selection structures, we're going to understand what they are. But the brackets, you can see here, this is acceptable. This is not acceptable. Again, when I say not acceptable, I mean from the perspective of readability of your code. It makes it a little bit hard for people, but this way it's a little bit better. So you can see here we got a lot of recommendations when it comes to how do you write a code that's easy for people to understand? So let's look here, for example. I'm trying to understand. Oh, now this I don't agree with, by the way. I usually, if it's a single statement, I don't use the brackets. But again, for a beginner, I will say yes. Go ahead and use those uh, curly brackets. Okay, so integer num1, and here it is, num1. What's the problem here? He's not using a camel case, so that's not a good idea. Using underscore, not a good idea. Number of boxes, user key. I'm not sure why is he complaining here. Let's see, variable parameter names are descriptive. Oh yeah, descriptive. Whenever you choose a variable name, choose something that describes what it is. What is B? What is key? It's really hard to tell. What are they? Constant, uppercases, always. Well, of course, but if it's two words, you have to separate it with underscore. And look here, that's hard to tell. This is all lower cases. This is maximum what? An integer character. What is he complaining here? Oh, let's see here. Visual, I usually declare early, not within a code. Okay. Now, as I said at the beginning of the class, you can think about any project as inputs, process, outputs. So whenever you create, let me just show you what they mean by this. I'm going to go back to my, you see here, this is wrong. Creating a variable in the middle of the project, this is wrong. This is supposed to be done at the beginning. All the variables need to be created at the beginning of your project, not in the middle. So that's why it's, again, this is just guideline for styles. The compiler will not complain about this, but it's always recommended for you to actually do it correctly. Function names are camel cases with uppercase first. Well, some may argue with that because not always, but it's okay. So you can see here, this is acceptable as well. Those are just, again, some advices about how do you write a code that's acceptable. And let me just tell you, by the time we get to the end of the semester, I am gonna look into those guidelines, and I will grade you based on how much you follow these guidelines. Of course, at the beginning, we're starting fresh. We don't know a lot about what is if a statement, what is a while statement. So that's okay for now. But in the future, or especially by the time we get to the project, this should be something you always put whenever you write a code. Now, the last part, we do have two examples here. The first one, again, it's all about salary calculation with variables. So what do we have here? We got a project. We have three variables: the hourly wage, the work hours per week, and the annual salary. So we have three variables. What are we supposed to do here? The hourly wage, $20, and the worker, he works 40 hours. So basically, the annual salary will be how much hours he worked per week multiplied by the rate of 1 hour multiplied by the number of weeks we have in 1 hour. Now, I do have some problems here. Which is the 50. This is what we call a magic number. Having an expression like this and multiplying something by a value, that's not a recommended. So look at this. He's telling you now here to declare and initialize variable work weeks per year. And I can think about this as a constant, but I'm not going to do that because he didn't tell me. I'll just put 50 here, put semicolon. So all I have to do now is replace this with 50 with the works per week. So the animal salary is going to be that. Multiply that by, well, why do I need to do this? I can just use the animal salary and divide it by 12. There is no need for this here. the whole point here is to use the annual salary. So I'm going to copy the annual salary and replace this thing. And I'll put it here. Now, we have a problem in this example here, because if you look here, the annual salary is an integer, and 12 here is an integer. So I'm not going to get the right answer for this. Well, there are one solution here. You can put 12.0. So now I'm dividing an integer by a double, so I'll get the right values. Let's see if there's any syntax errors. And here we go. Now let me just take this 0.0 away, and you will notice the results are going to look like 3333 with no decimal point. So we have this option, or we can come here and say static, I believe, underscore double. Let's see if he's going to like that. Nope, he didn't like that. Let me just make sure that I got this right. I think there's no underscore. Let me try that again. Nope, he doesn't like it. There's one way I use the old school of casting, which basically means you put double here. But this is not recommended these days. Yep, let me just see here. C++ casting double. I just want to make sure about the syntax really quick. Type conversion. Where is it? Come on. Dynamic. No, I don't want a dynamic. Here it is. Static cast. Yep, that's what I forgot. Static cast. Where am I? So I'll come here and type static underscore cast. Let me run it. What are you complaining about here? Let's see here. Static cast. Take this and put double. Yep, I think I should get it right. I don't know what he's complaining about. Double. Come on, where is it? Static cast double. Here it is. Oh, I know. It's not enough to put that. You have to put the number you're casting between the parentheses. Let's see if he's going to like it now. And here we go. Here's another example, very similar to what we had before. So you guys can have a look at those examples. And first name, I think, and try to answer those questions. They're just exercises for practicing. Okay, so let me go here, stop sharing, stop